There is a traveler moving through our solar system right now. A traveler older than Earth, older than the Sun, older than every history ever written by human hands. It is a relic from a time before our world existed, a fragment of a story that began somewhere far beyond the reach of our skies. And for the first and possibly the only time, it has crossed into our neighborhood, passing close enough for us to witness its presence, if only for the briefest moment in cosmic time. We call it 3I Atlas, an interstellar comet, a visitor from the deep. Imagine the scale of space for a moment. Imagine the sun not as a blazing ball of fire, but as just one star among hundreds of billions, each one surrounded by its own worlds, its own debris, its own orbiting fragments of ancient collisions. Now imagine those fragments drifting away from their home star systems, flung outward into the darkness by gravitational tides, by chaotic interactions, by the collapse of worlds, by the death of suns. Imagine these pieces drifting for millions, sometimes billions of years, not orbiting anything, just falling endlessly through a silence so vast that even time itself seems to dissolve. That is where 3I Atlas comes from. It is a relic of a place we will never see, carrying the chemical memory of a world we will never walk upon. Right now, as it passes through our solar system, we are watching it with everything we have. Telescopes on mountaintops, instruments aboard satellites, rovers on other planets, high-altitude observatories orbiting in the empty cold above Earth's atmosphere. We are studying it not because it poses any threat, but because this is the closest we may ever come to physically encountering something from another star. It is like a message in a bottle from across the galaxy, a letter written long before we existed, finally washing up on the shore of our solar system. When 3I Atlas was first detected on July 1st, 2025, nothing seemed extraordinary. The Atlas survey telescopes, designed to detect asteroids that could threaten Earth, picked it up as a faint, moving point of light. It was small, distant, barely noticeable against a backdrop of stars. But when astronomers began to calculate its orbit, they found something startling. Instead of looping around the sun in a closed ellipse-like planets, like moons, like comets born in the Oort cloud, this object was passing through on a one-way trajectory, a hyperbolic path. It wasn't circling anything, it was just passing by. There are only two reasons something moves like that. It was either pushed with massive force from within our solar system, or it came in from interstellar space. And nothing within our solar system could have given it that kind of push. Not Jupiter, not Saturn, not even the combined gravitational resonance of all the major planets. So there was only one explanation. This was an interstellar object. And suddenly, the faint little dot of light became one of the most important objects in the sky. Interstellar objects are so rare that when the first one, Oumuamua, appeared in 2017, it changed astronomy forever. It was unlike anything we had ever seen. Long, flat, tumbling, dark, moving in ways that challenged our understanding of physics. The second, Borisov, arrived in 2019 and behaved more like a traditional comet. But its composition hinted at different planetary chemistry. And then came Atlas, the third visitor, the biggest, the fastest, and perhaps the most revealing. What made Atlas immediately stand out was its speed. Everything in our solar system is held in place by the sun's gravity, and the closer something is to the sun, the faster it has to move to stay in orbit. Earth moves at 30 kilometers per second. Mercury, close to the sun, moves at about 48. But 3I Atlas was moving at close to 58 kilometers per second, while still near the orbit of Jupiter, far beyond the region where such speeds are typical. It was moving too fast to ever be caught by the sun. That speed was its passport. It was passing through, untouched, unstoppable, unbound. But speed was only part of the mystery. Something else made scientists lean closer, stare deeper, question harder. Atlas entered our solar system aligned almost perfectly with the plane of planetary orbits, the thin, flat disk in which the planets revolve around the sun. Space is three. Objects can enter from above, from below, from any angle. But Atlas came in from the side, aligned to within only 3 degrees of the ecliptic, a coincidence so unlikely that many astronomers described it as surreal. To understand how strange that is, imagine throwing a dart across a football field and hitting a coin lying flat on the ground, not from above, but perfectly along the surface. That is the level of alignment we are talking about. Something shaped this object's path long before it arrived here. Something guided or flung or influenced it in deep time. Tracing its trajectory backward, astronomers found that Atlas came not from the neighborhood of our Sun, but from a region closer to the center of the Milky Way. A region known as the thick disk layer of the galaxy, filled with ancient stars, some older than the Sun by billions of years. If Atlas formed there, then it may have originated in a star system that existed and evolved long before the Earth was formed. Which means that when Atlas passes by us, we are witnessing something older than everything we know. Older than every continent, every ocean, every life form that has ever walked the Earth. When we observed Atlas more closely, we began to notice that it did not behave like comets from our solar system. Most comets begin to sublimate water ice when they get within 3 to 4 astronomical units of the Sun. But Atlas began releasing gas when it was over 5 astronomical units away, stilled out beyond the orbit of Jupiter, where the Sun's heat would not typically melt anything but the most volatile ice. The gas coming off Atlas was carbon dioxide, not water. The ratio was 8 parts CO to 1 part water vapor. That composition is almost the opposite of what we normally see. This means Atlas has been shaped by temperatures far colder than anything in our solar system. It means the world it came from, or the environment where it spent most of its existence, must be unimaginably cold. A place where water remains deeply frozen forever, sealed below layers of exotic ices that require almost no heat to sublimate. As Atlas moved closer, the story became even stranger. A sudden surge of water vapor began streaming out of the comet face, powerful, as if something inside had cracked open. Not slowly melting, but bursting. Something had sealed water ice inside the object for billions of years, and only now, in its first encounter with a warm star in perhaps eons, was that seal breaking. And then there were the metals. Nickel appeared in the Coma before iron. That should not happen. Nickel and iron are produced together in stellar core, released together in supernova explosions, bound together in the planets and asteroids that form afterward. But Atlas was different. The nickel arrived first. The iron came later. Something separated them long ago. Something violent. Something ancient. Even the tail was reversed. In the early stages of its approach, Atlas formed a sunward-facing tail plume of dust and gas being blown toward the direction of the Sun instead of away from it. This only makes sense if sublimation pressure is stronger than solar wind. And that means Atlas was changing, evolving, reacting, almost like it was breathing. The best view we have of Atlas so far came not from Earth, but from Mars. On October 3rd, the comet passed closer to Mars than it will come to any planet. Rovers on the surface looked up and recorded streaks of light. Orbiters traced the halo, but we still have not seen the core itself. Not clearly. Not yet. We wait for December, when Atlas emerges from behind the Sun, when we see what the heat has done to it, whether it has fractured, whether it has survived, whether something inside has awakened for the first time in billions of years. And then it will leave. In March 2026, Atlas will pass near Jupiter. The Juno spacecraft may capture one last image. And then Atlas will fade, past Saturn, past the Kuiper belt, past the Oort cloud, past the boundary of our solar system, back into the long night, and it will keep going for millions of years, maybe billions more, until someday, in some distant era, it passes by another star, another civilization, another set of eyes that look up and wonder where it came from. We do not know what story Atlas carries. We do not know what worlds shaped it. We do not know what suns burned above the skies of its origin. But we know this: its presence here is not random. It is not meaningless. It is a reminder of how vast the galaxy is, how interconnected its history is, how ancient and powerful and strange the cosmos truly is. The universe does not send messages in language. It sends stones, ice, metal, dust, fragments of worlds that once were. Atlas is one such fragment, a relic of creation, a traveler from another dawn, a whisper across the void. When we talk about 3I Atlas, we are not merely discussing a comet. We are speaking of time itself, made solid, a memory that predates our world, traveling silently through the galaxy, a witness to events we can hardly imagine. When Atlas entered the domain of our sun, it crossed into a region of warmth and gravity and light that it may not have experienced since the earliest dawn of the Milky Way. And as we watch it, as we measure every flicker of reflected light, every spectral line, every shift in trajectory, we are not just observing a distant travel, we are watching a story unfold. A story written in ice and rock and dust. A story shaped by worlds we will never visit. Consider what it means for an object to survive for billions of years in interstellar space. Most matter that drifts between stars is eventually destroyed, bombarded by cosmic radiation, fractured by gravitational interactions, eroded by micrometeor collisions, or captured by passing stars. To remain intact long enough to cross the cold gulf of the galaxy, Atlas must be extraordinarily durable. It must possess a structure that is not fragile or loosely held together, but layered, dense, ancient. The chemical signatures we see tell us that it has been shaped by extremes, by deep cold that locked away volatile compounds, by intense heat that separated metals, by violent disruption that rearranged its interior. Atlas is not just a shard of ice. It is a fossil of an ancient catastrophe. To understand Atlas, we must imagine the world it came from. Not a world like Earth, not even a world like Jupiter or Neptune, but a world formed around a star we have never seen, in a star system that may no longer exist. Picture a young star in the early Milky Way, blazing bright in a nursery of dust and plasma. Around it forms a swirling disk of gas and debris. Planetary embryos collide, merge, fracture, reform. Some worlds grow large enough to carve stable orbits. Others are flung outward, condemned to drift. Debris is scattered everywhere. Moons tear themselves apart. Oceans freeze, atmospheres collapse. And in the middle of this violent dance, something happens. Maybe a gravitational resonance with a neighboring star. Maybe a supernova shockwave. Maybe a close encounter with another planetary system. Whatever the cause, objects are thrown outward at escape velocity. Out of the system, away from its sun. Hawaii from heat, away from warmth, into the endless cold between stars. Atlas was likely one of those exiled fragments, a piece broken from a world that once orbited a distant star, a shard of something larger, a survivor of destruction. And once it left its birthplace, it was alone. No sunlight, no planets, no gravity well to hold it. Only the slow drift through the dark. For 1 billion years, then another, until the galaxy rotated, until new stars formed, until others died, until civilizations rose, and fell and rose again on worlds scattered across the Milky Way. And still, Atlas drifted, silent, unchanging, waiting for nothing, bound by nothing, seen by nothing. And then, by a chance so rare that the odds stretch beyond imagination, it entered our solar system. It crossed into the sun's gravitational sphere, falling inward from the void. A traveler, arriving unannounced. But even as we watch it, we cannot see it fully. There are limitations to what science can measure. Telescopes tell us about its gases. Spectrometers tell us about its metals. But the core, the nucleus, the solid heart of Atlas remains unseen, wrapped in haze and dust. Only when the coma fades, when the heat recedes, when Atlas leaves the sun behind, will we briefly see its shape. And Evanton, the resolution may not be sharp enough to reveal the details we crave. We may learn everything and nothing. We may come away knowing this visitor was ancient, was layered, was complex, and yet still be unable to describe what it is. When Perseverance on Mars looked up and photographed Atlas, that moment marked the first time in history that one planet observed an interstellar object passing by from its own soil. The rover's cameras are designed to analyze rock, soil, minerals, everyday things. But that night, it recorded something not of its world, and not of ours. A streak of light from beyond. The image itself is faint, a blurred streak across a star field, but its meaning is immense. It is the first extraterrestrial photograph of an interstellar visitor, taken from another planet. Think about that. 2 worlds, Earth and Mars both, bearing witness to something neither world has ever seen before. Orbiters above Mars recorded Atlas differently. They measured its brightness curve, its coma density, its dust particle size distribution. The data was limited, but it was real. A handful of numbers representing an object older than the solar system. Small numbers, but numbers that will be studied for decades. And somewhere, stored in onboard memory, possibly unanalyzed, there may be a series of images taken by the Mars Reconnaissance Orbiter, the most powerful telescope that has ever orbited another planet. If those images exist, and they likely do, then locked inside them may be the clearest view humanity will ever have of an interstellar object. But they remain unseen, not because of secrecy, but because of timing, a shutdown, delays, bureaucracy. A moment where cosmic history brushed against human politics and slipped between them. We will get another chance. In December, when Atlas emerges from behind the sun, when its coma begins to shrink, when the gases cool, when the bright shroud begins to collapse, we will see what remains. Will it be whole? Will it be fractured? Will it be shedding pieces into space like scars opening under heat? No one knows. Comets from our solar system often break apart as they approach the sun. Their structural integrity fails. They disintegrate into dust and debris. But Atlas is not a comet from here. It is built differently. It has endured conditions no local comet has faced. It may be far stronger, or far more fragile. If it survives this solar encounter, it will continue outward. But before it leaves completely, it will approach Jupiter, the largest planet in our solar system, a world with gravity strong enough to tear moons apart. That encounter will not capture Atlas because its velocity is too high. But Jupiter will see it, and Juno, the spacecraft orbiting the gas giant, will have a brief chance to observe it. One last look, one last measurement, one last moment before the traveler disappears into the deep. And then Atlas goes home to nowhere. It returns to the dark, past the orbit of Neptune, past the Kuiper belt, past the Oort cloudy region where our own comets are born. Atlas will cross that boundary, the border between our system and the galaxy at large. And then it will be gone. The sun will shrink into a star among stars. The planets will fade behind it, and nothing but darkness will remain. What does it mean that this object came here? What does it say about our place in the universe? It means that everything is connected. The galaxy is not a collection of isolated stars, each locked in silence. It is a web of exchange. Worlds eject debris. Suns fling fragments outward. Material crosses light. Chemistry travels. The building blocks of planets and life do not stay where they form. They drift. They wander. They seed distant skies. Perhaps the origins of life on Earth came from such a fragment carrying amino acids or organic molecules, a frozen spark waiting for a home. Perhaps Atlas carries such seeds still. Perhaps on a world we will never know, under a star we will never see. Life was made possible by something much like this object. The universe is old. Stars are born and die. Worlds form and crumble. Matter recycles. Nothing is isolated. Everything touches everything else. When Atlas passes by Earth, we are reminded that we are not separate. We are not unique in the grand sense. We are one expression of a vast, ancient, ongoing story. The galaxy is alive with motion and exchange. Atlas is proof. And yet, even with all we have learned, the object remains silent. It does not speak. It does not explain. It simply moves, a traveler, a witness, a memory. When it leaves, we will stay behind. We will continue circling our sun. We will continue building cities, telling stories, searching for meaning. We will continue looking outward, wondering what else is out there, wondering who else might be watching, wondering what ancient travelers are passing through other skies, in other systems, seen by other eyes. Atlas will keep moving through the interstellar dark, past the reach of radio waves, into the future, a future in which Earth may no longer exist, a future in which our sun has burned out, a future in which new stars have formed and died, a future so distant it defies imagination. And still, it will travel, because that is what interstellar objects do. They are the memory of cosmic events, frozen into motion. They are the relics of worlds lost to time. They are the messengers of a universe that writes its stories, not in words, but in the movement of matter across the void. We were lucky to see Atlas. Lucky to witness it. Lucky to study a fragment of another world without leaving our own. Most civilizations in the galaxy will never see an interstellar object. They will never know that other star systems send pieces of themselves drifting into eternity. They will never know that worlds speak to each other, silently, across incomprehensible distances. But we do. For a brief moment, we stand at the window of the universe, watching something ancient pass by, knowing that it will never return. It is easy to feel small in moments like this, easy to feel insignificant. But the truth is the opposite. If we can detect Atlas, if we can study it, if we can understand it, if we can recognize its meaning, then we are not small at all. We are part of the universe. We are participating in its story. We are learning to read its language. Atlas is not just a visitor. It is a reminder that the universe is larger, older, deeper, and more connected than we ever imagined. A reminder that we are not isolated, that our world is not alone, that matter travels, that history travels, that stories travel, and sometimes those stories pass right through your sky. This is only one story among billions written in the stars, and we are just getting started. Hit subscribe, turn on notifications, and be here tomorrow. There is so much more to discover.